Alright, this video is going to be a trig review for honors physics. We are going to work a lot of problems that deal with triangles this year, and you need to understand the trig relationships about those triangles. So first thing I have is 3 different right angle triangles that are on the paper. Everything that we're going to do, it doesn't matter which way the triangle is drawn, but everything that we're going to work with will be triangles with right angles. In each and every one of these, you can see that the right angle is labeled. In every triangle, the line that is opposite, like directly across from the right angle, is always referred to as the hypotenuse. And so I'm going to label those with an H in each of these triangles. This one is directly across, making it the hypotenuse, and right here is the line directly across, making it the hypotenuse. Now, the other 2 parts of the triangle, I'm just going to call them side A and side B. You can refer to them any way you want to, but those can be referred to as the opposite and adjacent sides, but how you refer to them, it depends entirely upon what angle we are talking about. So if we are looking at this angle right here at the top in our triangle, I'm going to refer to this angle as theta. And I'm going to refer to this angle down here at the bottom as phi. Both are Greek letters, and it's just a way to refer to them. If theta up here would be 30 degrees, then that would make phi be equal to 60 degrees. That's not drawn to scale whatsoever, but just saying they have to add up to 90 degrees. If we're looking at the 30-degree angle, if we're looking at theta, then side A is adjacent to the 30 degrees. It's actually, this side is touching this angle right there. So we would say that A is adjacent to 30. But A doesn't touch any part of the 60-degree angle over here, phi. So A would be called opposite to phi. Side B is adjacent to the 60-degree angle because it's touching part of it. It is opposite to the 30-degree angle because it's not touching any part of that. We're going to need to use those terms, opposite, adjacent, and hypotenuse, in order to come up with our trig relationships. The same thing could be said of these triangles over here. I'm going to use them for a couple of example problems. The main relationship that we need to focus on that will help us out in class is a relationship many people have learned in class called SOHCAHTOA. What SOHCAHTOA stands for is for the relationship of the triangle sides and the angles for sine, cosine, and tangent. So is for sine. You're going to have the sine of some angle. I'll call it theta. That could be any degree. Sine of theta is going to equal to O, the opposite side, over H, the hypotenuse. And I'm just going to abbreviate with HYP. Ca is for the cosine relationship. The cosine of theta is equal to A, the adjacent side, over the hypotenuse. TOA is the tangent relationship. And the tangent of an angle is going to be the opposite side over the adjacent side. So what exactly does this look like? Well, let's take this middle triangle right here. And let's say that we have that this angle right here is going to be 40 degrees. And the base of the triangle right here on the side is going to be 25. And what we want to find is the length of the hypotenuse. So what we can do is we can figure out what we have and which one of these relationships we're going to use by thinking about whether we've got opposite, adjacent, hypotenuse, or what we're dealing with. We know we're going to have some trig function here. We're going to have something of 40 degrees, either sine, cosine, or tangent. I'm going to figure that part out in a minute. What I have next is, I know I have the hypotenuse because we're trying to find the hypotenuse. I need to figure out if this 25 is going to be opposite or adjacent. Well, 40 degrees is over here. the side that's 25 never touches the 40 degrees. So 25 is going to be opposite to the 40 degrees. So what I have is I have a side that is opposite and I have hypotenuse. And if you look through my options, opposite and hypotenuse goes with sine. So I'm going to be plugging it into this setup right here. So I'm going to have the sine and a class change. The sine of 40 degrees is equal to the opposite side, which is 25, over the hypotenuse. You can put in h or you can put in x. I don't know what the hypotenuse is. And then from there, we use some algebra skills to figure out what this is going to be. And I haven't worked this ahead of time. I'm making it up as I go along. The answer that I get is that the hypotenuse is going to be 38.9. I'm not working with sig figs at the moment. We've not covered that in my classes yet. So at some point, you know, maybe you'll know that that's not proper sig figs, but whatever. For right now, it's just about the trig. We'll do one more example using the triangle over here on the left. For the triangle on the left, let's say that we're going to do something different this time. We know that this angle down here at the bottom, we're going to have it be 20 degrees. And in this case, we are going to say that this leftmost side, the base, is going to be 35, and I want to be able to find this piece right here. I'm going to call it x. I want to find this missing side. So, same way we did before, we're going to have something, sine, cosine, or tangent of 20 degrees. But I need to figure out what I have. I don't know what the hypotenuse is, so it can't be sine or cosine because I need a number. I can't have two unknowns, which means we're going to be looking at tangent. We're going to have to do the tangent of 20 degrees. Now for tangent, I need opposite over adjacent. Well, the side that is opposite to 20 degrees is going to be the 35. And then the adjacent is x. X is touching the 20 degrees. So we're just going to put in x. And then we're going to use algebra, you know, to solve this. I didn't do it over here, but you're going to multiply both sides by x. And then those will cancel out. So then I'm going to have to divide both sides by the tangent of 20. So 35 divided by the tangent of 20 gives me that side x will be 96.2. And we have no units, but it's all about the idea of the trig. Okay. One more thing dealing with triangles that should be mentioned for class, so that's not pretty, is that in our word problems, the word problems will refer to some sort of an angle. So for example, if it talks about an airplane, and it says that you have an airplane, really quick airplane here, that is flying along, and it's flying through the air, here's the ground, and it says that the plane is flying at an angle of 30 degrees to the horizontal. Well, the horizontal is going to refer to the plane, like, well, kind of a different meaning of plane, but like the area where the plane is flying. The plane is flying along this dotted orange line. This is the horizontal that the plane is flying at. So if we're talking about an angle that is 30 degrees to the horizontal, that means we're looking at it kind of like this way. That the plane is flying at an angle of 30 degrees to the horizontal. Okay? And then, you know, if you're given other information about your plane, like if it says your plane is flying at an altitude of 350 meters, maybe it's coming down to the ground, whatever, well, then you've got your right triangle, you have an angle, you have one of your sides, you can start doing problems. It really doesn't matter in this case if I look at the triangle from this perspective or if I'm going to look at it, you know, like this, because my numbers are going to be the same as long as I make them mirror images of each other. Okay? If you're given a problem that has something like a mountain, so like here's my mountain, and it tells me that, like we had one in class today about a ski lift, if it says that my ski lift runs at an angle above the ground, then you'd kind of be looking like this to the top of the mountain. So if relative to the ground, that means we're looking at this angle. This angle up here would be relative to the top of the mountain. It's telling you with the words where you should put your angle at. So if the angle relative to the ground is 30 degrees, we're looking at the angle down here at the bottom, because that would make this one up top 60. Because right here, if you came straight down, even though you can't travel directly up the mountain, this is still your vertical, and it's going to be the base of your triangle. And here's your right angle, and now you're set to start working problems if you have some numbers. Like if I know that the vertical distance of my mountain is 700 meters, then I could figure out the distance or the length of the chairlift. So pay attention when it's talking about the angles. We'll keep practicing this, and that part should seem a little bit easier as time goes by. Feel free to contact me if you have any questions, and I'll do my best to help.